Okay, so continuing on from where we left off, we were talking about the difference between continuous and discrete graphs. So in this problem, it says the amount of water in a wading pool depends on the amount of time in minutes the wading pool has been filling, as related by the function rule. Graph the function rule and then decide, is the graph continuous or discrete? Remember, continuous is just a constant line all the way across, whereas discrete are individual points along the graph. So we'll talk about that in a second. First, let's graph the function rule. In this case, we're going to take 1, 2, 3, and 4 and plug it in for t in our function rule. So we end up with 3, 6, 9, and 12. And we're going to graph those here. We're not going to connect them yet. I just want you to graph the individual points first. So we have 1, 3, 2, 6, 3, 9, 4, 12. Okay, now it doesn't really tell us how large the wading pool is. Let's just say it can hold 15 gallons. So at that point, or 20, whatever, at some point you can only fill it up to a certain point, or obviously it will overflow. So let's just say we stopped at 12 gallons. The next part is deciding, is the graph continuous or discrete? So what we need to think about is asking yourself, would fractions make sense in this situation? Would it be okay if we only filled up the pool to 9.5 gallons or 9.3 gallons? Would that still make sense for this situation? And I would say it would. We could fill the pool up until it's, at the top, and we could fill it up at any number of gallons. So in this case, any amount of water would work or make sense in this situation up to when you have filled the wading pool. So I would go ahead and connect the dots together. Let's just say we stopped there, and we would say that this graph is continuous because any amount of water makes sense. Okay, for this situation. So you want to kind of decide. Sometimes fractions don't make sense. Like we had that vegetable problem the other day with the cases of vegetables. You had to buy a whole case. You couldn't buy 0.68 of a case. So in that situation, it would be a discrete graph, because only certain values make sense in that problem. But in this problem, you can use any amount of water, so fractional parts would make sense as well. Now we have our last example here. In this last example, we are graphing nonlinear functions. So in this rule, it's asking, what is the graph of this function rule? Notice we have an exponent. So that's going to kind of change the shape of our graph a little bit here. So I'm going to take these values for x and plug them in for x here, and we're going to find those values. Remember, on your calculator, I just want to make sure on your calculator there's like this little button like this. It's called a caret. No, it's kind of weird, but that's what it's called. And this button allows you to do exponents other than to the second power. So since we have x to the third power on my calculator, let's say I'm going to do -1. On my calculator, I would do parenthesis -1. Whenever you're doing negatives on your calculator, you should use parentheses around them. Otherwise, the calculator could end up giving you the wrong sign for the answer. So super important that you're using parentheses. And then I would press my little caret button here on the calculator, and then I would press 3. And then I'd go ahead and say +1 also. If you do it that way, in that order on your calculator, you should get the correct answer, which is 0. So there is a certain way to type those in to make sure that you're always getting the correct answer back. So if I plug in 0 here, I'm just left with 1. If I plug in 1 here, I'm just left with 2. If I plug in 2 here, we would have to do 2 to the third power plus 1. So that would give us 9. And then remember, when you're doing -2, if you're going to use your calculator, you would do parentheses -2 and then your caret button to the 3 and then +1. So if you type that correctly, you should get -7 on your calculator. So you might want to practice that and check that you're getting that answer. And then when we plug in -3 on your calculator, you should end up with -26. Although this last one is going to go off of my graph, so I'm not going to graph that one. I'm only going to graph the points that actually fit on the graph here. So we're just going to leave that one off. Now the rest of these points, I'm going to graph and put them here, and then we can see what the graph looks like. So I have 0, 1. So I'm going to graph that point, and then just go ahead and graph your other points. I have 1, 2, and then 2, 9. Kind of jumps up there. And then -1, 0. Then -2, 7. 2, 3, 4, 5, 6, 7. -7, I should say. Now, these are not going in a straight line. So what I'm going to do here is kind of start at the top, and I'm going to kind of wind my way down here to the bottom. So in general, this is the shape when you have a value to the third power. And so it kind of curves down here. This would be a representation of a nonlinear function rule. And the exponent kind of gives that away. If it was a linear function, it's not going to have an exponent. So something to keep in mind. Anyway, so that is the end of our lesson for today. Next, you will need to look in your book for the assignment, and there will be either a worksheet provided, or you can do your work on a piece of paper, but you will need some graph paper, okay? So that's it.